In this session, we will discuss about thermodynamic approaches, thermodynamic property, thermodynamic state, thermodynamic process, thermodynamic cycle. Thermodynamic approach is an analysis of thermodynamic properties. The properties such as pressure, temperature, volume, and so on. This analysis can be made in two different approaches. One is microscopic approach, which is called statistical thermodynamics, and another one is macroscopic approach, which is called classical thermodynamics. In microscopic approach, the individual molecules are analyzed. You can look at this system. This system contains millions of molecules. Each and every molecule is analyzed individually. Such an approach, we call it as microscopic approach. The microscopic approach is carried out at the molecular level. Whereas in macroscopic approach, all the millions of molecules are considered as a single system and we investigate the properties. Such an approach, we call it as macroscopic approach. What is the difference between the macroscopic approach and the microscopic approach? If you consider a cup of hot coffee, I can analyze what is the volume of this coffee, what is the temperature of this coffee, what is the pressure of this coffee, what are the ingredients in the coffee, the concentration, color, and so on. I consider the whole coffee or the entire coffee as my system and analyze the properties. Whereas, in case of microscopic approach, I analyze the individual molecules piecewise. See, look at this. This is one molecule, this is another molecule, this is another molecule, this is another molecule. So, I analyze the behavior of the individual molecules. Such an approach is microscopic approach. The macroscopic approach is very simple and requires only few formulas and only few properties are required. Whereas this microscopic approach is highly complicated and requires more and more mathematical methods and more variables are required for the analysis of the system. Coming to the property or thermodynamic property. Thermodynamic property is nothing but any characteristic that describes the condition of the system is called thermodynamic property. For example, mass of the system, volume of the system, pressure, and so on. If you consider the same hot coffee, all these properties, mass, volume, pressure, concentration, are the properties of the system. So there are three types of properties: the intensive property, extensive property, and specific property. Intensive property. If any property which is independent of the mass of the system, we call it as intensive property. These properties does not depend on the mass of the system. The best examples are pressure and temperature. The extensive property. Any property which depends on the mass of the system is called extensive property. The best examples, mass, volume, and so on. Now, let us consider some system. The mass of the system I have taken as 1 kg and its volume is 1 cubic meter, pressure is 1 bar and temperature is 80 degrees Celsius, let us say. Now, I divide this system into two equal portions. Let us see what happens to the mass, volume, pressure and temperature. The mass becomes half kg, half kg. The volume also becomes half, but the pressure and temperature remains constant. So, the properties which depends on the mass are called the extensive properties. And the properties which does not depend on the mass of the system, we call it as extensive property. Coming to the specific property. Any extensive property, maybe this mass, volume or any energy, can be made as intensive property by dividing with mass of the system. So, I have divided this 1 cubic meter by 2. It has become half cubic meter. So, this is the total volume. I denote it as V, uppercase letter V. Once it has become half, I have divided this extensive property by mass. So this property I call it as the specific property and I denote with a lowercase letter small v. This is called specific volume. This one is the uppercase letter V is the volume and the lowercase letter small v, I call it as specific volume. Similarly, energy also can be made as an intensive property by dividing with the mass of the system. Coming to the state or thermodynamic state. State or thermodynamic state is nothing but it is the condition of the system at any instant. Consider a piston cylinder arrangement in which some gas is taken, 1 kg of mass, 1 cubic meter of volume, 1 bar of pressure, 80 degrees Celsius temperature. At one instant, these are the properties of the system. Now, if I supply heat to the system, if I supply heat to the gas, what happens? The gas expands. The mass remains constant. The volume has doubled. The pressure has become half of the initial value. The temperature remains constant. This is the final condition of the system. Initially, the mass was m, volume was V1, pressure was P1, temperature was T1. Now it has become m, V2, P2, T2. So the state or thermodynamic state is the condition of the system at any instant. Coming to thermodynamic process. Thermodynamic process is the change in state of the system. Just as we have discussed that in the gas, the initial pressure was P1 and initial temperature was T1. After supplying the heat, it has become P2, T2. So that means there is some change in state from 1 to 2. Such a change in state of the system, we call it as process. This was the initial condition of the system, and this was the final condition of the system. This process may be of constant pressure, constant volume, or isothermal process. The process can be plotted in any two properties of the system. I have taken pressure in the y-axis and the volume in the x-axis. If I describe the change in state of the system between the points 1 and 2, it follows this curve. Depending on the process, the shape of the curve changes. Coming to the thermodynamic cycle, if the initial and final states of the system are same, then the system is said to have undergone a cycle. Consider this is the initial state of the system. Now I supply some quantity of heat. As a result, the system expands, the gas expands, and the piston pushes backward. Some work is done by the gas. Now the volume has increased and the pressure has decreased. Let it be state 2. If I compress this gas by pushing this piston forward back to its initial volume, becomes like this. And this is the final condition. This is the final condition 3, but this 3 has become 1. That means the initial and the final conditions are same. We can plot it on PV diagram. So look at this PV diagram. This is the initial condition of the system. After the expansion process, this is the condition of the system at state 2. Again, the gas is compressed. Again, it is being brought back to its initial condition. So you can say that the initial condition and the final condition of the system is the same. So this is a cycle. Thank you.